This is Chapter 1, Functions, Section 1.1, Functions Given by Formulas. This is almost the traditional algebra way of giving functions. Functions of one variable. Consider the following equation. Y equals 3x minus 4. Now those that recall stuff from your high school algebra days, you know that this is a line. It's in the y equals mx plus b form. We say that the equation is solved for y because it says y equals on one side. If it said x equal on one side, we say that it's solved for x. We prefer to have it solved for y. So the variable x is called the independent variable. Notice it's the one that's part of the formula because we're able to choose values for it without any real restrictions. Restrictions would be something like you can't take square roots of negative numbers or you can't divide by 0. So that you can basically say x is any number. The variable y is called the dependent variable because as the equation is given, its value depends on the value of x that we choose. So notice it's easier to pick an x. We've got to do a little bit of work in order to figure out y. Notice it's just some basic arithmetic, but it is still a little bit of work. So whichever variable is solved for, that is usually considered to be the dependent variable. The variable that's part of the formula is usually the independent variable. In the x and y world, we like x to be the independent variable and y to be the dependent variable. Each value of x will produce one and only one value for y. When this happens, we say that y is a function of x. In general, the dependent variable is a function of the independent variable. So the functional relationship is given by the formula. In this case, y equals 3x minus 4. So if someone asks you what is the relationship between x and y, in this problem, they're related by y equals 3x minus 4. You know, like triple the x and then subtract 4. That's how you get y. Function notation. The function notation for the above equation, y equals 3x minus 4, is this. Okay, instead of having the y, because notice the right-hand side is the same, 3x minus 4. Instead of having y, we have this thing, and that's read as f of x. So it's not a new way to evaluate a function. It's simply notation that you've got to get used to. So this is read as f of x equals 3x minus 4. So the f and the parentheses around x, that's f of x. Some people will say f at x, but f of x is more common. This lets you know what the independent variable is. It's the gadget in parentheses. And notice in here, there's really only one variable, namely x. So that has to be the independent variable. So the terminology for f of x equals 3x minus 4. Number one, f is the name of the function. So we've called the function f. We could call it g, in which case we'd have g of x equals 3x minus 4. The expression in parentheses, the x, that is called the argument of the function. Every function has to have an argument that you do something with. Number three, the expression on the right-hand side of the equation, in this case it's 3x minus 4, is the formula or rule for the function. It tells you what to do with the argument. In this case it says multiply it by 3 and then subtract 4 from that result. Evaluating a function. The definition. To evaluate a function means to replace the argument with numbers and or variable expressions, perform any arithmetic, and then simplify the answer. When it's all numbers, we usually just say crank out the answer. So some examples. We let f of x equal 2x squared minus 4x plus 11. G of x will equal 5x minus 9. And h of x is equal to negative 15. We're going to evaluate each of the following. Simplify your answers. So again, here are three functions. They will appear every time we're doing these problems. Our first one is f of negative 4. Our solution. This formula means, in the formula for f, so back up here with 2x squared minus 4x plus 11, we're going to replace all the x's with negative 4 and do the arithmetic. Okay, students usually just say, you want me to plug in x equals negative 4? Yes, we're going to plug in x equals negative 4. So f of negative 4 is going to be 2 times negative 4 squared minus 4 times negative 4 plus 11. Notice once we replace the variable with a number, we're now doing the my dear Aunt Sally. So we're first going to square the negative 4. Okay, you can also do minus 4 times minus 4. So let's see, it's going to be 2 times 16 plus 16 plus 11. Now, according to my dear Aunt Sally, I should do 2 times 16 next. So I have 32 plus 16 plus 11. And then when you crunch that all out, you get 59. So our final answer is 59. Now, a warning. Do not write f of x equals 59 or x equals 59. They're wrong. It is f of negative 4 that is 59. In this example, f of x is 2x squared minus 4x plus 11, and x is equal to negative 4. The x is always the gadget inside parentheses. Okay, it's the argument of the function. So if you had to write anything other than your final answer of 59, remember it's f of negative 4, which is equal to 59. For number 2, I've got g of negative 4. Our solution. In the formula for g, replace your x with negative 4. So I'm going to have 5 times negative 4 minus 9. I get negative 20 minus 9, which is negative 29. That's our final answer, negative 29. Number 3, h of negative 4. So in your formula for h, we're going to replace x with negative 4. Okay, but in the formula, there is no x. There's only the number negative 15. So when there's no variable in the formula, it's called a constant valued function. So no matter what you give h of x, it's always going to give you back negative 15. So a constant valued function only gives back that numerical value. So h of anything is going to be negative 15. So h of negative 4 is negative 15. So constant valued functions are kind of nice to work with. There's no work to do. Number 4, f of z. So in the formula for f, back up here, replace all the x's with z's. So f of z will be 2z squared minus 4z plus 11. You're done. That's all you do. So notice it's nice to evaluate a function at a letter. There's really nothing to do. Just swap out whatever the letter is. Please don't do anything else to that. Number 5, g of 2t. Notice in this one we have a combination of a letter and a number. So in the formula for g, you're going to replace the x with 2t. We're going to have 5 times 2t minus 9. Now notice there is a little bit of work to do. You can do the 5 times 2 and get 10. So we'll have 10t minus 9. So notice if there's any sort of number involved when you're doing the evaluation, there is some work to do. If it's just a letter, there's typically no work to do. For number 6, I have h of x plus 5. Notice again a combination of numbers and letters, but h is a constant valued function. So with constant valued functions, there's never anything to do. So h of anything, remember, is negative 15. So h of x plus 5 is also negative 15. Constant valued functions, there is no work to do. They only produce the number that's on the right side of the equal sign. Number 7, I have g of x plus 5. Okay, g has slightly more than just a number, so there is some work to do. So replace the x with x plus 5. We're going to have 5 times x plus 5 minus 9. Now do notice if I distribute the 5, something will happen. So I'll have 5x plus 25 minus 9. It's the 25 minus 9 that we've got to deal with. Was that 16? So I get 5x plus 16. That's your final answer. It's the number crunching that can sometimes lead to careless errors, so we'd like to be able to hand this over to our calculator. So part C, evaluating functions with the calculator. So we can enter function formula into the calculator and use the calculator to evaluate the function when the argument is a number. This only works when the argument is a number. If you have a combination of letters and numbers for the argument, you got to do it by hand. So we enter the function formulas using the y equals on the calculator. This can be useful if we have to evaluate the same function at several different numerical values. We're going to illustrate with an example. Now if you only have to evaluate the function at one particular number, or only evaluate it one time, this is a lot of work just to do it one time. So this is useful if you're going to evaluate it several times. So our illustration. I'm going to let f of x equals negative 3x squared minus 7x plus 18. Okay, we're going to evaluate f of negative 6, f of 14, and f of 9. Notice we're evaluating the same function at 3 different numbers, so that might be worth entering it into the calculator. So our solutions. Step 1. We enter f of x into the calculator. We'll put it in the y1. So here are the keystrokes. Okay, you do your y equals the negative for the negative 3, and 3, your x t theta n key, the x squared key, minus, so notice we're at this stage, 7, and then again your x t theta n key, plus, and then your 18 key. So you get something that looks like that. So negative 3x squared minus 7x plus 18. Let me go ahead and put this on my calculator so I can play the game with you. So let me minimize that for a moment. Let's see, here's my calculator. So let's see, I got y equals, so negative 3x squared minus 7x plus 18. then I'm going to quit the screen. So second of mode is quit. So notice in blue it says quit. So I've quit the screen. So notice I was there. So step 2, we're going to quit the previous screen, which I just did, and they're going to press the VARS key. So if you press the VARS key, you get this. This is your VARS menu. So you've got VARS, Y VARS, and color. You may not have all these depending upon what version of the calculator you have. Okay, I want to do the Y VARS. Remember, I put my function in the Y equals, so I'm doing Y VARS. So using the navigation keys, the arrow keys on the keypad to scroll over to the right in order to highlight the Y VARS. And you get this screen. So here are your choices for the Y VARs. Now, we're doing a function. So notice it's already highlighted as choice number 1. So just press Enter. And you get this. And this is where you have to remember, which Y did I put it in? So we put it in Y1. If you didn't have it in Y1, you would use your navigation keys to scroll down to whichever one you have it, and then press Enter. So remember, we put F into Y1, so it's already highlighted, just press Enter. Okay, now let me get kind of caught up to where we are on my calculator. So again, VARS. Scroll over to Y VARS. I'm doing a function. It's in Y1, so just press Enter. And now I have this screen. I'm getting ready to evaluate Y1 at something. So to get caught up in the lecture, so I've got that. Now remember, part A is f of -6, which in the calculator's notation would be Y1 of -6. Now notice the argument for the function in parentheses, you're going to do the same thing with the calculator. So for step 6, to evaluate f of -6, we key in -6 in parentheses. So we're going to have this. So let me get back to my calculator. Oops, come on, calculator. Open parenthesis, -6, close parenthesis. Okay, and when I press Enter, and lo and behold, there it is, -48. So f of -6 is -48. Let's see, do I get the same screen here? Yes, we do. This is a lot quicker by hand, but notice you had to do a lot of keying to get here. So if you're only evaluating the function at one number, it's not worth all this nonsense. You may as well just do it by hand. But if you're going to evaluate the same function at several numerical values, it might be worth doing. So of course, if you key in the function wrong, you're going to get every single one wrong. So be sure you have the function correct. Okay, to do the f of 14, so I've noted to answer part A, f of -6 is -48. So the cursor, if I want to do f of 14, I do second Enter to edit. So the cursor is flashing. You can't tell on that screen, but if I do it here, so second Enter. Okay, the cursor is flashing, which means I can now edit. I want to go back and change -6 to 14. So 14. Okay, my parentheses are still closed. Press Enter. I get -668. So f of 14 is -668. And for f of 9, I can do second Enter again. Second Enter. I want to change the 14 to a 9, so let me type over and have 9. Now notice I got to get rid of that 4, so let me just delete it. And press Enter. So f of 9 is -288. So this is a lot quicker than trying to do all 3 by hand. So pressing again second Enter and change 14 to 9, I get that. So f of -6 is -48, f of 14 is -668, and f of 9 is -288. So again, that's great if you're evaluating the same function at several different numerical values. If you have a letter involved, you got to do it by hand. Functions of several variables. Sometimes the value of one variable depends on the value of several other variables. The classic example is the weather. There are so many variables that affect the weather, that's why they always get it wrong. So as an example, the volume V of a cylinder depends on the radius R of the cylinder and the height of the cylinder. Okay, in case you're wondering, a cylinder is a tin can, like a tin can. So we can write the volume of a cylinder as a function of 2 variables. Okay, it's a function of R and H. So V of RH is equal to pi R squared H. Okay, now pi is not a variable, it's a constant. Okay, your calculator has a built-in value of pi. You should always use it unless you're told not to. So here's a function of 2 variables. You got to give me R, you got to give me H. You have to give them in that order. So notice R comes first, then H. So if we write V of 37, that means we want the volume of a cylinder that has a radius of 3 and height of 7. So that is different from V of 73, in which case the volume the cylinder is going to be dependent upon a radius of 7 and a height of 3. Remember, it's radius and height because of the way we've written it. We've written it as V of RH. The way the function is written here lets you know which variable corresponds to which letter. The radius is first, the height is second. Some examples. Number 1, I'm going to let f of xyz equals 2xy minus 8yz plus 3. Evaluate the following: f of 1, 2, 3, f of 2, 1, 3, and f of 0, 0, 1. Now, even though we're doing all numbers, the calculator is geared toward functions of one variable. We can make it do functions of several variables, but it becomes rather cumbersome. So by the time we get it all entered in, we could have already been done and gone home. So our solutions here. f of 1, 2, 3. So x is 1, y is 2, z is 3. So 2 times 1 times 2, minus 8 times 2 times 3 plus 3. Now, if you wanted to do this on your calculator, you can, but the numbers aren't too hideous. So that's what, 4 minus 48 plus 3. So I get negative 44 plus 3, I get negative 41. So f of 1, 2, 3 is negative 41. For part B, f of 2, 1, 3. So x is 2, y is 1, z is 3. So I have 2 times 2 times 1, minus 8 times 1 times 3, plus 3. Just be sure you put the right numbers for the right letters, because after that it's just basic arithmetic. So I've got 4 minus 24 plus 3. It's negative 20 plus 3. I get negative 17. And for part C, f of 0, 0, 1. So x is 0, y is 0, and z is 1. So 2 times 0 times 0, minus 8 times 0 times 1, plus 3. Well, that's 0, minus 0, plus 3. The answer is just 3. How hard it is to do the arithmetic comes down to how nasty is the formula and how bad are the numbers that we give you. Okay, this one wasn't too bad. Number 2. Susie has invested in stocks, bonds, and real estate. Her income from investing S dollars in stocks, B dollars in bonds, and R dollars in real estate is given by capital R for revenue of SB little r is equal to 65S plus 120B plus 300R, where capital R is in dollars. So notice it's stocks, bonds, real estate in that order. Part A says, find Susie income from investing $400 in stocks, $800 in bonds, and $1,000 in real estate. Part B, write the functional notation for Susie investing $600 in stocks, $300 in bonds, $800 in real estate. So part B, you just want the notation. You don't want to do the arithmetic. And part C is, what is the interpretation of R of 700, 1,000, 200? What does it mean? Don't evaluate it. What does it mean? It's only part A that's being evaluated. So our solutions. For part A, S is 400, that's her stocks. B is 800, that's her bonds. And little r is 1,000, that's her real estate. So we're looking at R of 400, 800, 1,000. That's what we're evaluating. So we're going to have 65 times 400 plus 120 times 800 plus 300 times 1,000. Okay, and then you just do your number crunching. Okay, I would suggest using a calculator to avoid any careless errors. Though, of course, if you press the wrong key, you've got an error anyway. So when you do all the crunching, you're going to get 26,000 plus 96,000 plus 300,000, which works out to be 422,000. So what's your income? $422,000. Now, when you're doing the work in WebAssign, sometimes the dollar symbol is already there, so you don't need to put it, and oftentimes they'll tell you not to put the dollar symbol. But again, if it's money, they usually have the dollar symbol there for you. You're just entering in the numerical value. You're just entering in the 422,000. And whether you're supposed to put a comma or not, it's usually your choice. Remember, when you're doing the homework, do the part A first, so that way you'll get a second chance if you've accidentally entered in more information than they wanted, or you have some sort of a typographical error. Remember, the part B, once you've entered and checked, that's it. You don't get a second chance on the problem. Okay, for part B, write the functional notation for Susie investing $600 in stocks, $300 in bonds, and $800 in real estate. So according to this problem, our S is 600, right? That's the stocks. The bonds is 300. And real estate is 800. So we're looking at R of 600, 300, 800. That's the functional notation. Again, don't evaluate it. Don't forget your parentheses. Don't forget your commas. And for part C, what is the interpretation of R of 700, 1,200? So that says we're going to find her revenue, her income from investing $700 in stocks, $1,000 in bonds, and $200 in real estate. That's the interpretation. This would usually be a multiple choice type question on in WebAssign. So please read the choices carefully, because sometimes, just to be honest with you, he does try to trick you. He has some little subtle differences. He'll scramble up the order. He'll leave off with a 0 or something, so watch out for those. And please, on the multiple choice, please don't leave them blank. There's nothing wrong with guessing and getting it right. Example number 3. Let p of xy equal e to the x plus y to the e. Evaluate the following. Round your final answers to 6th place or right of the decimal point. Okay, clearly we're going to need our calculator, because we've got this number e involved. So for part A, we're looking at p of 3, 2, part B is p of 2, 3, and part C is p of 0, 0. And we're looking at 6 places to the right. So let me get out Mr. Calculator here. Let me turn it back on. Let me clear this nonsense out. Remember, I already have something in y equal from the last time, so just clear it out. So I can't put the functions in there because I'm only allowed to put one variable. So let me just quit that. And let me set my float. So my mode, we're going to float on over to 6 places, like it said. That way the calculator will round. I won't have to strain my brain to figure it out. And then quit. Okay. So for part A, p of 3, 2. So again, I've set my calculator up. I set my float to 6. Again, I don't want to have to think about rounding. Okay? I don't want to hurt myself. So p of 3, 2 is EQ plus 2 to the E. Now, if you're looking for the exact value, that's it. So I get out the calculator. Okay, E cubed. So remember, E to the x is second of ln. So second ln e to the third. Okay, get out of the exponent. Plus 2 raised to, now notice I'm wanting the e power. The e power is right there. That's an e. I don't know if you can tell or not, but second e. Okay, and then just press enter. So 26.666423. For part B, so there's my answer. Part B, p of 2, 3. It's e squared plus 3 to the e. Okay, I did my second enter and I edited. Okay, so if you want to see that. So, second enter. Let's do some editing. That 2 needs to be a 3. And then that other 3 needs to be a 2. 27.202047. So p of 2, 3 is 27.202047. And lastly, part C, p of 0, 0. So if I do my second enter again, so second enter, make that 3 a 0, make that 2 a 0. 1. Okay, it turns out it's exactly 1. It's not even an approximation, it's exactly 1. But to do what the directions said, 1.000,000. So there's A, B, C. That's the end of section 1.